We are going to solve Addition Mathematics, Paper 1, Specimen Paper B for examination from 2025. Time for the paper is 2 hours and the total marks for the paper is 80. Question number 1 is related to trigonometry. Now, it says that the diagram shows the graph of y is equal to a sine bx plus c, where a, b, and c are integers. Find the values of a, b, and c. Now, if you see this graph, we have, this is the graph of sine, and sine graph starts from 0. So, this is the axis. We can say that c is minus 4. It is at minus 4. And the distance from maximum point to the axis is amplitude. So here amplitude is 2 units. So we can say that A is 2. For the value of B, we can see that till pi there is 1.5 cycle. 1 cycle is completing over here and then half cycle. It means that within 2 pi there will be 3 cycles. So we can write the value of this B is 3. So A is equal to 2, B is equal to 3, and C is equal to minus 4. Now question number 2 says the solutions of the equation absolute of 5x plus 2 is equal to absolute of 3x minus 4 are x is equal to a and x is equal to b, where a is greater than b. Find the value of absolute of 2a minus 3 minus absolute of b minus 1. First of all, we have to find out the values of x using these. Now, we have here absolute of 5x plus 2 is equal to absolute of 3x minus 4. So, we can take here 5x plus 2 is equal to 3x minus 4. And another time, we can take it as 5x plus 2 is equal to minus 3x plus 4. 5x minus 3x will be 2x. Minus 4 minus 2 will be minus 6. So x is equal to minus 3. Here we have 5x plus 3x is equal to 8x. 4 minus 2 is equal to 2. So x is equal to 1 upon 4. They have said here that a is greater than b. So this is the value of a because this is greater than minus 3. And this is the value of b. Now we can take out the value of 2a minus 3. So a is 1 upon 4 minus 3 and minus 3 minus 1. So when we will solve it, we will get 1 upon 2 minus 3 and minus 4. So this will give us minus 5 upon 2 because we will multiply 2 by 3, it will become 6. 1 minus 6 is minus 5, so it will be minus 5 upon 2 and this is minus 4. So as we have to, it is absolute, so we have to take positive values. So 5 upon 2 minus 4, which is equal to minus 3 upon 2. We are going to solve question number 3. Find the values of k such that line y is equal to 9kx plus 1 does not meet the curve y is equal to kx squared plus 3x into 2k plus 1 plus 4. This is the question related to quadratics. So if it says does not meet the curve, it means that we have to apply b square minus 4ac is less than 0. So first of all, there are two equations given. We can equate these two because these both are in terms of y. So 9kx plus 1 is equal to kx square plus 3x into 2k plus 1 plus 4. Now we will take all the terms on this side. Kx square plus, we will simplify as well, 6kx plus 3x minus 9kx plus 4 minus 1 is equal to 0. We can write this as kx square plus 6kx minus 9kx will be minus 3kx and plus 3x plus 3 is equal to 0. So A is equal to k, B is equal to minus 3k plus 3 and C is equal to 3. Now b square minus 4ac is less than 0. So we will substitute the values. So minus 3k plus 3 can be written as 3 minus 3k. Minus 4 into a is k and c is 3 less than 0. So we'll use identity to expand this. 3 square is 9. 3 multiplied by 3k is 9 and 9 twos are 18. So minus 18k. Then 3k square is 9k square. Minus 4 into k into 3 would be minus 12k, which is less than 0. So we can rearrange as well as we can simplify. Minus 12k and minus 18k will be minus 30k plus 9. So now we can take 3 as common. 3k square minus 10k plus 3 is less than 0. So we have here 3k square minus 10k plus 3 is less than 0. When 3 will be taking on that side, it will be 0 divided by 3 and it will be 0. So now we can solve by middle term breaking. 3k square, 3 3s are 9 and we have here minus 10. So 9 1s are 9. So minus 9 and minus k are the factors. Minus 9k minus k plus 3 is less than 0. So we can take 3k as common, k minus 3, and minus 1 is common, k minus 3. So we have here 3k minus 1 and k minus 3 is less than 0. Now, k is equal to 1 upon 3 and k is equal to 3 are the critical values. And if we'll draw a graph for this, we'll be having 1 upon 3 almost over here. And 3 we can take over here. And as it is 3k square minus 10k plus 3, the coefficient of k square is positive. So the curve is minimum curve. So it will be like this. And we have to consider the lesser part of the curve. So the curve which is below x-axis, because it is less than 0. So this part we have to consider. And we have to find out the values of k on this part. So you can see the range of values of k is from 1 upon 3 till 3. So we can write it as k is greater than 1 upon 3 and less than 3. So our answer is k is greater than 1 upon 3 and less than 3. Now question number 4. It is given that cot theta is equal to minus 2 under root 6 for theta is greater than pi and less than 2 pi. Cot theta is equal to minus 2 under root 6 means tan theta is equal to minus 1 upon 2 under root 6. So tan is negative here, right? And here the range is given from pi till 2 pi. It means that from 180 degree till 360 degree. So if the range is given from 180 till 360 degree, so the third quadrant and fourth quadrant are included here. And here it is minus sign. So cot theta is negative in fourth quadrant. So it means that we have to find the value of sine theta in fourth quadrant, right? So as we have to find out sine theta and we have just given the value of cot theta. So first of all, we need to see, we have to change this into, we have to take square so that we can get cot square theta. Square of 2 is 4 and square of under root 6 is 6. So 4 multiplied by 6 is 24. So now we can apply here the identity cot square theta is equal to cosec square theta minus 1. We have cosec square theta is equal to 25. We know that cos square theta is inverse of sine square theta. So we can write sine square theta is equal to 1 upon 25. So sine theta will be equal to square root of 1 upon 25. So sine theta is equal to plus minus 1 upon 5. As we have to take out the value in fourth quadrant, so the final answer is to be 1 upon minus 1 upon 5, because in fourth quadrant, the value of sine theta is negative. In B part, they are saying find the value of cos theta, giving your answer in surd form. As we know that cot theta is equal to minus 2 under root 6. So cos theta upon sine theta is equal to minus 2 under root 6. So we have cos theta is equal to sine theta multiplied by minus 2 under root 6. So we have already taken out the value of sine theta as minus 1 upon 5 multiplied by minus 2 under root 6. So we have here 2 under root 6 upon 5. And as we have to find out cos theta in fourth quadrant cos theta is positive. So 2 under root 6 upon 5 is the answer. In question number 5, we have to solve the simultaneous equations. One of the equation is 3y minus 2x plus 2 is equal to 0. Another equation is xy is equal to 1 upon 2. Now we can make x the subject or we can make y the subject. If we will make y the subject, we will be getting 1 upon 2x. But if we will make x the subject, we will get the equation as x is equal to 1 upon 2y. So when we will substitute here 1 upon 2y, 2 and 2 will be cancelled out. So it's better to make x the subject from second equation. This is equation 1. This is equation 2. So from equation 2, we have x is equal to 1 upon 2y. Now we have to substitute it in equation 1. So equation 1 will become 3y minus 2 into 1 upon 2y plus 2 is equal to 0. So this 2 and this 2 will be cancelled out. So we have here 3y minus 1 upon y plus 2 is equal to 0. We can multiply the whole equation by y. So this will become 3y squared. Here this y and y will be cancelled out. So we will be left with y plus 2y is equal to 0. So now we have 3y squared plus 2y minus 1 is equal to 0. We can do middle term breaking. 3 multiplied by 1 is 3 and it is minus 3. So we have to make factors of minus 3 in such a way that we get plus 2y. So we have y squared plus 3y minus y minus 1 is equal to 0. So 3y, y plus 1 minus 1, y plus 1 is equal to 0. So 3y minus 1 and y plus 1 is equal to 0. So we have here 3y minus 1 is equal to 0 and we have y plus 1 is equal to 0. So we have here 3y is equal to 1 and y is equal to 1 upon 3. Y is equal to minus 1. We can substitute these values of y in equation xy is equal to 1 upon 2. So xy is equal to 1 upon 2. X multiplied by 1 upon 3 is equal to 1 upon 2. So we have x is equal to 3 upon 2. We can do cross multiplication. So it is 3 upon 2. So here we can substitute y as minus 1 is equal to 1 upon 2. So x is equal to minus 1 upon 2. So we have got coordinates as 3 upon 2, comma 1 upon 3 and minus 1 upon 2, comma minus 1. Now question number points P, Q and R have coordinates P minus 4, comma minus 8, Q 2, comma 4 and R 10, comma 0. In a part, they are saying show that the line PQ is perpendicular to the line QR. Whenever two lines are perpendicular, when we multiply their gradients, that gives the answer as minus 1. So we will take out the gradient of PQ, for which we'll be using the coordinates of P and Q. So 4 plus 8 divided by 2 plus 4 by 2 minus y1 upon x2 minus x1. And here 0 minus 4 upon 10 minus 2. 4 plus 8 is 12. 2 plus 4 is 6. Minus 4 upon 8. So we can simplify it. 4 ones are 4, 4 twos are 8. 6 ones are 6, 6 twos are 12. And 2 ones are 2, and 2 ones are 2. So it is minus 1. So minus 1 is equal to minus 1. We have to find the equation of the circle which passes through P, Q, and R. It's not necessary to draw the figure, but for your understanding, I have added this figure over here. As we know, the coordinates of P are minus 4, comma, minus 8. So minus 4, comma, minus 8. This is the point P. And Q is 2, comma, 4. So 2, comma, 4 is over here. And R is 10, comma, 0, which is over here. We have already proved in the previous part that PQ and QR are perpendicular to each other. So if we draw a line from P to Q and Q to R, then here it is a right angle. Now, if here it is a right angle, that means that PR is a diameter. So if we take out the midpoint of PR, that will be the center of the circle, right? So center of the circle is equal to midpoint of PR. So we already have coordinates of P and R. The coordinates of P are minus 4, comma, minus 8. So, and the coordinates of R are 10, comma, 0. So minus 4 plus 10 upon 2, comma, minus 8 plus 0 upon 2. Minus 4 plus 10 is 6. 6 divided by 2 is 3. So it is 3, comma, minus 8 plus 0 is minus 8. Divided by 2 is minus 4. So the center of the circle is at minus 3, comma, minus 4. So it is almost over here, 3, comma, minus 4. The general form of the equation of the circle is x minus a whole square plus y minus b whole square is equal to r square. So we have already taken out the values of a and b. A and b are the coordinates of the center of the circle. Now we have to take out r square. So for r square, we can use the coordinates of either P and the center of the circle, or center of the circle and R. We can name this point as M. So now we have M as 3, comma, minus 4, and we have R as 10, comma, 0. So if we'll take out the distance from here till here, we will get the radius. So radius is equal to under root 10 minus 3 whole square plus 0 plus 4 whole square. So now we have here 10 minus 3 is 7. 7 square is 49 under root 49. 4 square is 16 plus 16. So we have under root 65. So now we can write down the equation of circle x minus 3 whole square plus y minus b. So here we have minus 4, so we can write it as plus 4 whole square is equal to r square under root 65 square. So the final equation will be x minus 3 whole square plus y plus 4 whole square is equal to 65.